In our last lesson, we learned about finding the open interval of convergence using the ratio test. And in this lesson, we're going to fill in some of the gaps, some of the details that we kind of glossed over. But let's set the stage by repeating what we did last class. So we want to find all the values of x for which this series, x minus 1 to the nth over n, converges. So we can start with the ratio test. So we want to find the ratio of the nth term, the ratio at the nth term, which would be x minus 1 to the n plus 1 over n plus 1, divided by, so I'm going to multiply by the reciprocal of n over x minus 1 to the nth, which simplifies the x minus 1 to the n plus 1 over x minus 1 to the nth. There's one additional x minus 1 in the numerator, so that's all that will be left after we cancel. And the n over n plus 1, there's nothing we can do to reduce that. And so what we do next is we take the limit of that. We call this L, by the way. The limit of that ratio, really the absolute value of that ratio, as n approaches infinity means as we get towards the infinite term. Well, that would be the limit as n approaches infinity of x minus 1 times the limit as n approaches infinity of n over n plus 1. And the reason why we separate them out is because the first part, the x plus 1, which by the way I should put in absolute value, doesn't have an n in it. So the limit of x plus 1 as n approaches infinity is just minus 1. And then the limit as n approaches infinity of n over n plus 1 would be the horizontal asymptote of n over n plus 1, which is just 1. So this whole limit is just equal to the absolute value of x minus 1. And we know that we need the limit of the ratios to be less than 1 in order for the series to converge. So whenever the absolute value of x minus 1 is less than 1, which means x minus 1 is between 1 and negative 1, which means x has to be between 0 and 2. Fantastic. That's our answer. Except there are 3 choices that have that same answer. And this is where we left off last class. We got to this point and we said, all right, that's good for now. What we have to do now is figure out, well, what about when x is exactly 0 or when x is exactly 2 at those endpoints? Does the series converge when x is 0? In which case, the choice would have to be one of these two. Does the series converge when x is 2? In which case, if it does, it would have to be that one. So that's what we're going to figure out right now. In order to do that, what we need to do is look at the series itself at those specific values. So what we're going to do is plug in x equals 0 and plug in x equals 2. So when x equals 0, oh, these are the wrong ones. When x equals 0, looking up here, if that equals 0, then my sum is the sum of 0 minus 1 over n, which is it's an alternating series, 1 over n. So that would be negative 1 over 1 plus 1 over 2 minus 1 over 3 plus 1 over 4, etc. We're going to find out if that series converges. And then the other one would be the sum of 2 minus 1. So I can write that out, 2 minus 1 to the n over n. And the question is, does that series converge? Now, I want you to notice this is a very different question from what we had before. And that's a big deal. Our question has changed. The question before that we answered last class was, when does the series converge? When implies you're finding an x value. And that's why our answer was an inequality. We had a set of x values that fit, that made the series converge. But now we're asking a slightly different question. We're asking, does this series converge? Notice how there's no longer an x in here or in here. We've taken them out because we've plugged in values for them. And now the question is, does this series converge? In this lesson, we're going to learn how to answer that question. We do a set of tests that we can try on a series to figure out if it converges or not. And that is what we're going to walk through in the next video. And then we will come back to this question to answer it at the end.